Alright everybody, welcome to the video on solving exponential equations using logarithms. Now let's just take a quick review of what we have done in the past, and that is if I gave you, let's say, 3x equals 27. Alright, now in this case this is a very nice problem because 3 to the third equals 27. We could also write it like this: 3 to the x equals 3 to the third, and because they have the same base they have the same exponents, which means x equals 3. So we've kind of taken the algebraic way and kind of worked with finding common bases, and in that case it works out all nice and happy and everybody goes home happy. But in this case, not everything is perfect in this world, and so if I gave you the problem like this, example 1 is the fact that 2 to the x equals 10. Now I've used this example maybe a couple times in class, and we have a problem on our hands because we can't take 10 to a base 2 and put it to some exponent. Okay, and that's what we're trying to do here. We're trying to find the magical number 2 to what power equals 10. And so to do that, we have to use a particular formula called a change of base formula, which states that log base b of x equals log base a of x divided by log base a of b. Now the key of this particular formula is this part right here, is if we take the log base of the same number, taking the this portion right here, the x, divided by the b, we will find our answer. Now, what we have here is we don't have necessarily a way to just put in log base 5 of x and log base 5 of b, but we do have a nice thing in our calculator which has the log function, which stands for, let me just put this right here, it really stands for log base 10. And we also have the ln function. Now you can use either one because in both cases ln stands for log base e. So if we took ln x divided by ln b, we would get the same exact answer of just pressing log x divided by log b. Okay, and I'll go through some examples here in this first portion right here. Okay, give me a second while I get my calculator real quick. Write down the example problems there. Alright, back at you. Alright, so what we have is, in this case, we do not have a nice way of finding this, but what we can do is use what we've learned about logarithms, meaning if I take both sides to log base 2 to the x equals log base 2 to the 10, you'll notice that, wow, that looks like it more complicates things. But in all actuality, this property that we have learned, that if we have log base 2 of 2 taken to an exponent, that this exponent comes in front. So we have x times log base 2 of 2 equals log base 2 of 10. Now why this is significant is because we see that log base 2 of 2. Well, we know from our experience that 2 to what power equals 2? Well, that would equal 1. So it's really saying x times 1 equals log base 2 of 10. And so this just means that x equals log base 2 of 10. And then now I'm going to use my change of base formula. So I'm going to actually use log here. So if I took log 10 in parentheses divided by log 2, and I'll write this out here in just a moment. So if I took if I type this in my calculator, what you're going to type is log 10 divided by log 2, you're going to get your answer of 3.322. We'll round to the nearest thousandths. All right? And so that's kind of the basis of what we're trying to accomplish, and you'll notice that we do take log base 2 because that is the base of my exponential function. That's where the x exists, is up there. Okay, so that is the first thing we want to do. So at the basic level, that's what we're trying to accomplish here. Now all we're going to do in example 2 and 3 is we're just going to throw a couple more little algebra steps in there, but the basic concept still exists. So for example, this is number 2 here. So if we have 6x to the x plus 2 minus 3 equals 5, okay? The first thing I need to do is I need to isolate the exponential function. So I'm going to add 3, so I get 6 to the x plus 2 equals 8. Now again, you'll notice that there's no way I can put 8 into a base that works, or 6 into a base that works, and so I'm going to have to use logarithms. So I'm going to take both sides to log base 6. I chose 6 because that is the base of my exponential function, and I took x 6 to the 8. All right, and my next step is same thing I did on that last problem. This x plus 2 is going to come in front, so I have x plus 2 parentheses log base 6 of 6 equals log base 6 of 8. And we notice from our experience log base 6 of 6 is 1, so technically that just cancels out. And so I have x plus 2 equals log base 6 of 8. Now what I'm going to do is I'm going to do all this work now on my calculator. So I'm going to first find out what log base 8 of 6 equals. So I press log 8 divided by log 6. And you get something that looks similar to this on your calculator. X plus 2 equals 1.16, let's say 1 dot 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 dot. We're going to keep that in our calculator, and all we're going to do is then press the -2 button in our calculator, and we get an answer of x equals negative 0.8394. Well, down to the 10,000ths, I guess. Doesn't really matter too much. And so that is my final answer. Okay, so I encourage you to go through that problem on your own and just kind of make sure you're getting the gist of it. You type that again, typing in your calculator, you're going to put log base 8 divided by log base, or log 6. I keep saying base. It's log 8 divided by log 6, meaning that this log base 10, log base 10. Okay, you could also use ln, you'll get the same exact answer. Okay, next part here, last part is just the most complicated problem we'll run into. So if we look at this particular problem, we have 3 times 4 to the 3x minus 2 plus 1 equals 10. Okay, so all I want you to do is try to figure this out by yourself here. Pause the video. And here we go. So first thing I want to do is isolate the exponential function. Okay, by doing so, now I have this 3 times the exponential function. So to get rid of the 3, I just divide both sides by 3. So now I have 4 to the 3x minus 2 equals 3. And now we're just at this exact same situation we've been in all these problems, which now I'm going to take both sides times log base 4. So let me rewrite that. Log base 4 to the 3x minus 2 equals log base 4 to the 3. And because I've done that, this is going to come up front. So now I have 3x minus 2 log base 4 of 4 equals log base 4 of 3. And this cancels out. So 3x minus 2 equals log base 4 of 3. And to save time here, I'm going to just give you the answer. So we have log 3 divided by log 4. And then I'm going to keep that number in my calculator, add 2, divide by 3, and I get an answer of, according to my estimations, 0.9308. All right. So hopefully you came to the same answer. If you have a dispute, please let me know, and we'll go over it tomorrow. Thank you very much, and have a fabulous day.